Alright guys, so this is meant to help you with your second lesson in Edgenuity, and the first thing I want to stress to you is that your questions will not be in the same order. In fact, you may not see all of these questions. However, these are all the possible questions you can have, so just keep that in mind as you go through these. Alright, so on this one, on my number one, they're asking you for the axis of symmetry to be x is equal to 3. So if you guys remember, your axis of symmetry is going to be the line that divides your parabola in half, right? So it goes through the vertex, it goes through the minimum or maximum. So if we're looking for something that if I draw a line straight down the middle, it's going to cross through on the x-axis, x equals 3, hence the equation that it comes from, right? Because it's a vertical line. So if I look on the first answer choice, so this one is, if I cross it, it's going to be maybe not right at -2, but maybe closer to -1. If I do it here, this one, notice it's crossing at x is equal to -3, and then if I go here, that looks like, oops, is x is equal to 1, and then if I draw a line on this one, okay, notice that axis of symmetry is going to be right at x is equal to 3. Okay, now on this one, they're asking you for a maximum to be located at -4, 2. So first things first, if your graph has a maximum, remember that means it's the highest point. So that means it has to look something like this, right? Because this right here has to be your maximum. So this one right here is out. So if you're looking for a point that has -4, 2, notice right here, there's that -4, 2. Right here, I have a +4, 2. Okay, so this one's kind of leading us back to from the other one. All right, so in number 3, when they're asking you to figure out where the on the interval it's increasing. So remember, increasing just simply means that the graph is going up. So if I'm looking at my quadratic here, from here to here, looks like it's going up. Now the interval notation is a little bit confusing, but essentially that's why they have this labeled, is we're looking at the x values, so it's increasing from -5 to, this little symbol means infinity. So remember, that just means that it goes on forever, right? So it's increasing from -5 to infinity. Okay, on number 4, the X-Intercept. So if they didn't give you this graph, we can graph it on Desmos, but since they gave it to us, remember your X-Intercepts is where it crosses the X-axis. And so looking at here, looking at my points, it only has 2, and this point right here is going to be 2, 0. So when we read that X-Intercept, we go to the right 2, but since we're not going up and down, that coordinate is 0. And then here it is -6, 0. Okay, which graph has a y-intercept of 3? So remember, your y-intercept is where it crosses the y-axis, and your y-graph, or your y-axis on your graph is this one right here. So you're just looking at which of the graphs crosses that y-axis at 3. Now, number 6, they're asking you if the a value in the function in the form is negative. So on this one, I'm going to kind of look at different graphs and see what happens. So if I graph different graphs with different a values, so say -2x squared plus 6x minus 8. So notice that that graph is going to be opening downward. If I am crossing it, or if I graph another one with a different negative number, okay, so what they have in common, okay, so what you're going to notice is that they are all going to be facing downward. They're going to look a little bit different, but since this is a negative value, again, they're all going to be opening up downwards, and so what's going to happen is that it's going to, the vertex is always going to be a max. Okay, so the Y-intercept. So when they don't give you a graph, again, this is a good time to use Desmos, so that way you can go ahead and graph it. And so we're going to go ahead and clear these out. So you're going to graph x squared plus 3x plus 5. And again, your y-intercept is going to be where it crosses the y-axis, so 0, 5. You can also look at your equation. So if it's in standard form, your y-intercept is always going to be that number at the end. So kind of either graphing it or just by looking at the equation. And then on this one, so the axis of symmetry, there's actually an equation that we don't spend too much time on. And that equation is negative b over 2a. So they're essentially asking you what would this the b value have to be if the axis of symmetry is 3/2. And your a value in this case is actually the first one, so right there it's 3. So I can simplify this a little bit and say negative b over 6 is equal to 3/2. And the easiest way to do this is to solve this like a proportion. So 2 times negative b is equal to 6 times 3, which is 18. And when you divide by negative 2, your b value has to be negative 9. Okay, so number 9, they're asking you for the range. So remember, the range is your y values. So we're looking at my y-axis right here. So we're looking at where does that graph start and where does it stop if it has a stopping point. So notice that the lowest point that it goes is negative 11. And this one actually just keeps going up, so there's no maximum or no stopping point. So what that means is your y values just simply have to be greater than or equal to negative 11. And on this one, where is it increasing? So the same idea as we had in the other question, it's increasing when the slope is positive. And so notice that it's positive from here, which we're going to call infinity because it technically keeps going. And it changes directions right at, looks like 1.5. So we can say that it is increasing from negative infinity. So negative infinity is just down here, right? That means that it just keeps on going and going and going. And it all goes all the way up to 1.5. And then from here, it's going to then be decreasing. So my axis of symmetry, same idea as we did on the other one. Remember, the equation is negative b over 2a. The a value is the number in front of x squared. And we know we want that to equal 6. So negative b 1/4 of 2 is going to give me 0.5 is equal to 6. And I can just put that as 6 over 1. And again, I'm just going to solve that as a proportion. So negative b times 1 is equal to 6 times 0.5. That just gives me negative b. And that gives me 3. Divide by negative 1. So my b has to equal negative 3. All right, so in this one, we're just going to use Desmos to graph it. So I would just graph each one and then see which one matches up. So I'm going to start right here. I'm going to graph this one just so you guys can see it. All right, so the equation that they want me to match it to is 1/2 x squared plus 2x minus 6. And then I can zoom out a little bit. And so you can kind of match the scale that it has, and the scale that we're looking at is 10 to 10. And so if I'm looking at the graph specifically, where is it crossing the x-axis and the y-axis? And so looking at that, it's crossing it here and here, and it has a y-intercept of negative 6. So looking at my graphs, the only one that could really match it is going to be this one. All right, which is true? So before I can decide which is true, which is false, I need to go ahead and just graph this. So I'm going to graph negative x squared minus 4x plus 2. And then looking at this, what are some things that I know are true? So the domain is x is less than or equal to -2. But remember, unless it's a real world quadratic, the domain is always going to be all real numbers because it doesn't really have a stopping point left or right. Now the range, they're saying y has to be less than or equal to 6. So if I'm looking at this, notice that is true because the maximum is right here at 6. So the y's do not go, the graph does not go above y is equal to 6. The function is increasing over the interval -infinity to 2. So what they're saying, increasing from -infinity, that just means from down here to 2. And then it decreases. So we can see that matches what our graph looks like, right? It's coming from -infinity and it's increasing right till -2. And it says the function is decreasing over the interval -4 to infinity. So -4 infinity, notice that x equals -4, it's actually still increasing. So we know that that is not true. And then the function has a positive y-intercept. So the y-intercept is 2. So that is positive. So that is a true statement. All right, so you're going to look at the graph here and you're going to look at this, again, kind of looking at the same way. So remember the domain is going to be your x values. So unless it has a real world restriction, which one, this one does not, my domain will be all real numbers. The range of the function is all real numbers. Well, that's not true because if you look here, the minimum is at -6. That means that there are no y values below -6. Okay, so my range is actually y has to be greater than or equal to -6. The vertex, so the vertex is 1/4 and -6 1/8, so that looks about right because your vertex is right there. The function has 2 x-intercepts. That is correct. So there's an x-intercept here and an x-intercept here, so it does have 2 of them. And then the function is increasing over the interval -6 and 1/8 to infinity. So we actually look at the x-coordinates here. So -6 and 1/8 is off the chart. So that is a false statement. It is increasing from about 1/4 to infinity, right? Because that kind of covers this half of the graph where the slope is positive. Okay, which true is if b is equal to 0? So this would be a good one, again, we kind of, as we graph them, to see. So the b value is right here. So if I just graph random parabolas, 2x², but what I'm going to make happen is I'm always going to make that b value 0 to see what happens. So that's +2, and if I graph another one, let's say 3x² plus 0x -1, and then let's do one more, y is equal to 4x² plus 0x plus 3. Okay, so what you'll notice what they all have in common, right? So if I look at these, it says the axis of symmetry will always be positive. Well, the axis of symmetry is actually 0, so that's not true. The y-intercept will always be the vertex. That's true in this case, right? Look, it's crossing the y-axis right where it's minimum, or if I had a negative value here where its maximum would be, but it'd still be crossing it right at the y-axis. The function will always have a minimum. So notice that on this, when I made this -4x, now has a maximum, so that's not true. The graph will always have 0 intercepts. Well, not necessarily, because that red one right here didn't have any because it doesn't cross the x-axis. So in this case, the y-intercept will always be the vertex. Okay, so the axis of symmetry of the function, what are the coordinates of the vertex? And so you're looking at, again, just graphing this one. Okay, so if I graph -x² minus 10x plus 16, and you might have to zoom out a little bit, right? So my vertex is at -5 and it looks like 41. Okay, what is the x-intercept? So again, you're just going to graph this one in Desmos. And I have x squared minus 16x plus 64. And we might need to zoom out. And again, you'll just identify the x-intercept, which in this case where it crosses or where it touches the x-axis, which looks like it's 8, 0.